Today we're going to be talking about two different things. First, we're going to start off with how to solve proportion equations. This is really just an extension of solving those multi-step equations, sometimes with variables on one side and sometimes with variables on both sides. So first, let's take a look at a standard proportion. These are ones that you've been solving since probably 6th or 7th grade. So if you remember correctly, whenever we have a ratio is equal to another ratio, if we want to find that missing one, we can multiply our diagonals. So I can do 3 times p, and I can do 9 times 5. Alright, now I've got a bit of an equation to solve here, so I can start by simplifying. Remember, our steps to simplifying or to solve an equation is first simplify both sides, then solve. So 3 times p equals 3p, 9 times 5 is 45. Now I can go ahead and start solving. So the inverse of multiplying is dividing, so I'm going to divide both sides by 3, and then we're left with p equals 15. Alright, so that was how to solve a basic proportion. But what happens when we get one that looks like this? Alright, well up here we have the star. It says don't forget to use parentheses. Whenever you have a proportion where you've got more than one term in one of the spots, we need to put that term into parentheses. Do that first. Okay, that should be the very first thing you do. Now, just like I did over here, I'm going to find my circle my diagonals. So I'm going to do 3 times a minus 8. Remember how we put those parentheses there? We're going to include those when we bring it down. And then I'm also going to do 10 times 9. So here's my 3 times the a minus 8. The a minus 8 has to be in parentheses. Alright, so let's simplify. Let's start by simplifying the left side. So I have 3 times a, and then I have 3 times negative 8. So that gives us 3a minus 24. I check to see, can I do any more simplifying on this side? I can't, so now I'm going to come over here and simplify this side. 10 times 9 is 90. Alright, so now we can start our solve process. So in order to isolate this term, I'm going to add 24 to both sides. When I do that, those cancel out, and we are left with 3a equals 114. Our last step is to divide, so we can divide both sides by 3, and we're left with a equals 38. And then don't forget to circle your answers. Alright, let's come down and take a look at another one. Same type of problem, only this time my variable has a coefficient. So I'm going to put my parentheses around this part of my proportion, this section. Alright, and now I'm going to circle my diagonals, and it doesn't matter which diagonal pair you start with. I have a tendency to always start with the one with the parentheses in it. I like that on my left side. So I'm going to start with that 5 parentheses 2b plus 8, and then my b times 6, or I just wrote it out as 6b. Draw my line, and now I can simplify this side. Distribute my 5 to the 2b, distribute my 5 to the 8. When I do that, I get 10b plus 40. I can't simplify anymore. Bring my 6b down. Alright, now we have a choice to make. I need to get these two variables together, so I have to decide which one to move. Since my constants are already here on the left, I'm going to move my 10b over to the 6b. So I'm going to subtract 10b from both sides, which means these ones here will cancel out, and we're left with 40 equals negative 4b. My last step then, to isolate the variable, is to divide both sides by negative 4, and we're left with negative 10 equals b. I'm going to use that symmetric property and just flip my answer around. I really like it better when my variable is on the left side. Alright, let's do one more of these together. Alright, this time I've got 2 spots that need parentheses. The 2x plus 3 and the 3x plus 9. I'm going to continue the same way I did before. So I have this set of diagonals, and I have this set of diagonals here. Alright, so when I bring them down, I've got 6 times 2x plus 3, and then I have 5 times 3x plus 9. Make sure you use your parentheses. Draw my line, and now I'm going to simplify. So I can simplify this side by distributing my 6 to the 2x and the 3. That gives me 12x plus 18. I cannot simplify anymore here, so now I'm going to distribute this side as well. I'm going to do the 5 times the 3x, and then I'm going to do 5 times 9. When I do that, I get 15x plus 45. Now I need to get my two variables together, so I need to make a decision. I personally prefer my variables to be positive, so I'm going to move my 12x over to the 15x. So I'm going to subtract 12x from both sides, and when I do that, those cancel out. And then I can come down, and I'm left with 18 equals 3x. All right, next step, I need to isolate the x, so I'm going to divide both sides by 3. And we're left with 6 equals x. And again, I'm going to use my symmetric property, and I'm going to flip that answer around because I like my x on the left side. Alright, so now go to the next page, and you have 4 problems that I want you to try on your own. Go ahead, pause the video now. Okay, let's go to the next page. Now we're going to talk about special cases. So we're still talking about solving those multi-step equations, but now we're going to get into these special cases. Equations can have no solutions, they could have one solution, or they could have infinite solutions. All the equations we've dealt with so far have all had one solution. So today our focus is going to be on no solutions and infinite solutions. So what does that mean? Alright, well, an equation with no solution means there's no value for the variable that will make the equation true. When we work out the equation, we end up losing our variables, and we end up with a number that does not equal the other number. And this may not make sense at first, but once we get down to our examples, you'll see what I mean by this. One solution is what we've been dealing with all along. There's only one possible value for the variable that will make the equation true, and our answer is usually written out as x equals a number. Infinite solutions is where all values from the real number system will work to make the equation true. And in this case, we end up with, our variables are lost again, but we end up with the same number on either side of the equal sign. Alright, so let's check this out. Let's see what this really looks like. So first we're going to start with some equations that are infinite solutions. I'm going to do the first one, and then I want you to try the next two. So I'm going to start by drawing my line. I need to get my two y's together, so I'm going to subtract. I'm going to take this 8y and I'm going to move it over to here by subtracting. So I'm going to subtract 8y. These cancel each other out. And now I can come over here to simplify. Well, 8y minus 8y is 0. So those are also out of inverses, which means they also cancel each other out. So anytime they make 0, they cancel out. So now all I'm left with on both sides is 1 equals 1. And we look at that. Is that a true statement? It is. So this means we've lost both of our variables because they've canceled out on both sides. We're left with a true statement, so we have infinite solutions. So how do we write that in set builder notation? So this is one that gets a little weird looking. So we start with our brackets, and then in this case we use y, so we're going to have our curly brackets and then y such that y, and then the new part. we have this kind of curvy E, and then what we call a double stamped R. Now for you guys to draw a double stamped R, it would just look like this. Let me do this. So a double stamped R, when you guys are just writing it, would look like this. You would just draw two lines and then make an R. Okay, so that's how you can write a double stamped R. It's really that R with an extra line. Okay? So in the print, it looks like this. All right, so what on earth does this all mean? So this reads, for the set of all y's such that y is an element of the real number system. Right, so this is basically saying that y can be any number out of the real number system. And the real number system is just all the numbers that we use on a regular basis. All right, so now I want you to go ahead and try these two. I want you to write your answer in set builder notation just so you get familiar with how to write it out in this format. Okay, so go ahead, pause the video now. All right, let's take a look at equations with no solution now. All right, so draw my line. I need to get my two variable terms together. So I'm going to take this 16h and move it over to the left. And do that by subtracting 16h from both sides. And when I do that, these two here will cancel each other out. Come over here to do my math, and 16 minus 16, well, that also equals 0. So once again, they cancel each other out. So what are we left with? Well, now we're left with 7 equals 16. Is that true or is that false? Well, that's false. So when we're dealing with math, here's what we need to make sure that we do. When we have something that's not true, okay, 7 does not equal 16, we have to put a slash through our equal sign. So that's a must, okay, because 7 does not equal 16, we put the slash through our equal sign. All right, so this means that there's no solution. We need to know how to put that in set builder notation. This one's actually pretty nice and pretty easy. Our set builder notation looks like this. It's just a set of parentheses with nothing in it. We call that an empty set because our set has nothing in it. There's no number that can go in for h to make the two sides of this equation true. All right, now I want you guys to try these two on your own. And that will conclude our notes. I'll see you in class next time.